Hello everyone, welcome to Study Tech, home for electrical engineering students. In this video, we are going to discuss PWM. If you have studied or if you are studying the power electronics, you will know that the PWM, which stands for pulse width modulation, is a very useful technique. In this video, we are going to discuss the concept behind the PWM. Before coming to the PWM in power electronics, how to generate it, where it is being used, as the questions are being asked in the interviews, I can give you the idea that we generally use in other aspects, like when we say the word which is called the voice modulation, right? The term voice modulation we use now. What is it? Voice modulation. Voice modulation. What is it? Why we use this term on voice modulation? What happens? Look, whenever someone is reciting or whenever someone is singing, according to according to the mood of the song, sometimes the pitch has to be high, sometimes it has to be low. So what the singer or the artist is doing, he is the tone of his or her voice is being changed according to the mode of the poem or the song, etc, etc. So that is basically, it is the changing of the voice according to the requirement, we call the voice modulation, right? So the answer lies here. Whenever we say the pulse width modulation or the pulse width modulation PWM for power electronics, it stands for pulse width modulation. Okay, fine, but it is actually, we are it is a pulse. Like say it is a pulse. This time being the period t, this will be capital 2t. So width of the pulse, look, from starting to some point there is no signal. It can be a voltage signal. Okay, so up to this time, let us say t1, there is no signal, and from t1 to capital T there is the signal. So now what can happen, that if I want, I can change the signal something like that. From 0 to some time, this is a capital T. See, what is happening is off time is decreasing. So I can change the pulse. Right. Similarly, this can happen also. Like this will happen periodically. Okay. That initially there is the pulse, and after some time pulse is not there. This can happen. Okay. So this might be the capital T and this might be the small t1. So this is the thing, that is giving a period, the pulse is there and the width of this pulse. This is the width. Width of this pulse can be changed or can be modulated. That is called the pulse width modulation technique. Now I know you are thinking, why I will change this pulse, where it is being used? Well, fine. Look, whenever we have to give, instead of giving a steady voltage, sometimes we need to give a pulse voltage to control the speed of the motor, the pulse of the pulse voltage. Sometimes I need to give the short pulse. Sometimes I need to give a very small pulse, right? So the voltage variation will be there. So this is the thing, that is, you can change the pulse according to your requirement. Now there are many techniques, there are many control strategies. I'm not going to that. Whenever this question is being asked during, let us say, the interview, okay, they may ask you, that is, what is PWM? Immediately you will answer that the pulse width modulation, the short form, right? Then they will ask you, what do you mean it? So then you can explain the whole thing in this way. I know that is, in the interview, if you give the answers in a very conceptual manner, the interviewer will know that he or she knows the thing. Okay, so this is a pulse width modulation. In the next slide, I am going to show you how can we generate this. Okay, so there are two modes how to generate, right? There are two modes. One will be I'm calling the analog approach, another being the digital approach. Here I am showing you the analog approach. This is a comparator, right? as we know from the analog electronics, this is a comparator, and the function of this comparator is it is taking two input and is giving one output. There is in the positive terminal, okay, and there is a negative terminal. If this positive terminal input signal voltage is higher than this negative terminal input voltage, you will get the output will be high, okay, and if this positive terminal voltage is lower than the negative terminal voltage, the output will be low. As you, this is the logic. Using the op-amp, you can make this comparator and make this circuit, okay. So in this comparator, look, this is a triangular wave, this is a sawtooth waveform we are giving. Let us say we are giving the sawtooth, I can change it. So sawtooth waveform is given here, and this is DC pulse is given. This is called the sawtooth because it looks like the saw tooth of the saw, and this is a DC voltage, right? Now I will compare these two voltages. The comparison is happening here. Look, this is a sawtooth voltage and this is a DC voltage, okay. Now whenever from this point to this point, let us see the period. This is a 2t. What is happening here? Look, whenever this sawtooth signal is high during this portion, sawtooth signal is high, you are getting the output. Whenever the sawtooth signal is lower, you are not getting the output. Simply. So you are getting this voltage. Now what will happen if I increase the DC level or if I decrease the DC level? Look, this voltage will be something like that. This is the sawtooth, right? If I increase the DC level, you will get the pulse width will be very small, right? Pulse width will be very small. And on the contrary, if I give the DC level lower, something like that, look, you will get very high width of the pulse. So it is just about your requirement, how much pulse you need. So just by varying this DC level, so definitely DC level will have some limit up to the max value of this other tip of this sawtooth waveform, that you will get the pulse can be changed accordingly, right? So this is a analog approach by which you can make this pulse, okay. Let us go to the next slide and show you one more interesting thing, that is sometimes I require that the pulse will look like this. This is my capital T. This will be the period of the pulse, and during this mid portion I need the pulse. During the mid portion I need the pulse. Then what to do? Take a comparator in the positive and the negative, okay. Sorry, should write positive negative here. Then give a triangular pulse, and here give a DC pulse. What will happen? Look, then definitely you will get this sort of voltage. This is a triangular wave, okay, and this is a DC. Now look, whenever this triangular waveform is high during this portion and during this portion, you will get the output and the output. Now having this pulse, the output, you can feed this voltage to the MOSFET to switch it. As you know, the MOSFET will be switching whenever the pulse is there, and whenever the pulse is not there, it will be off. MOSFET, IGBT, different devices are there in power electronics. You can give them the switching as a switching pulse, okay, and they will work. So this is the thing, the way you can generate. Here you can modulate the width of the pulse just by varying this DC level. Understood now? So this is the thing. This is a concept behind pulse width modulation technique. This is a technique. Pulse width modulation is a technique that can be used anywhere in power electronics. Okay. So this is the way by which you can generate the pulse width. There are another form how to generate the pulses, that is I told you in the digital way, that is using 555 timer, okay, using microprocessor,